To talk something called partial fraction decomposition. So it has to do with rational functions, and if you remember, a rational function is the quotient of two polynomials, so you're going to have one polynomial in the numerator and one polynomial in the denominator. So looking at this problem, let's see, where could you start? Let's say maybe you think, okay, well, 1 over x times x minus 1 is equal to 1 over x squared minus x. So maybe you start with that. The problem is that you still don't know how to integrate this 1 over x squared minus x dx. So what's really awesome about partial fraction decomposition is it gives you a way to break down the original equation into the sum of two different quotients that you can actually integrate, that you know how to integrate. So the first thing we're going to do here is we're going to recognize that 1 over x times x minus 1 is equal to a over x plus b over x minus 1. So how can we say that, or why did we say that? Basically, this is what partial fraction decomposition tells us, and it's basically just saying that something over x plus something over x minus 1 is going to equal this initial 1 over x times x minus 1. So starting there, what we're going to do is we're going to get on the right side, we're going to have to give everything a common denominator, and the common denominator is the original x times x minus 1. So this first term, a over x, is going to need an x minus 1 term. So we're going to multiply x minus 1 to top and bottom. And remember, we can do that because that's essentially just multiplying by 1. This b term is going to need an x term times x minus 1. And this equals 1 over x times x minus 1. Okay, so if you see what we did there is we just gave the right-hand side, we gave both of them a common denominator, so now we can actually add the top. So I'm actually going to simplify this first part, the a times x minus 1. So that's going to give me an ax minus a plus bx over x times x minus 1. So now if you notice, we have these two sides and they are equal. The denominators are the same, so that means that the numerators have to be the same. So what we're going to do from there, we're going to go up here. The numerators tell us that 1 equals ax minus a plus bx. Bx. So that tells us I'm actually going to combine the ax and the bx, and I'm just going to factor out the common factor, which is x. So I'm going to get a plus bx minus a equals 1. So if you notice on the left-hand side, we have no x term. So what that tells us is that a plus b has to equal 0, because there are no x's on the left side, so on the right side we can't have any x's either. So then from there, we can simplify this a little bit more, and we'll get a equals minus b. So now what we have left is we have our constant term, which is 1, and then we have this minus a. So that tells us that 1 is going to equal negative a, and a is going to equal positive 1. Oh, sorry, I was right the first time. Negative 1. Here, let's just cross it out. A equals negative 1. Okay. So now we know what a equals, and we can use that to plug into this equation over here on the left to find b. So if we just plug negative 1 in straight for a, we would get negative 1 equals negative b, and that would mean that b equals 1. B equals 1. Okay, let me scroll down a little bit. There we go. Okay, so where were we? Let's go back up. What step am I looking for? Oh, here we go. Okay. So now, if we go back to, I'm going to change colors. If we go back to this part right here, let's plug in our a and our b, and then continue the problem from there, because that's going to give us something that we can integrate. So we're going to have equals a, which is negative 1 over x, and then our b term is 1, so plus 1 over x minus 1. So now, just to recap, what we did was we took this original function here and broke it down into the sum of two different things that we know how to integrate. So now what we're going to do is we're going to continue on with our integration. So I'm going to go ahead and just write this second one first. So this equals the integral of 1 over x minus 1 dx minus the integral of 1 over x dx. So now if you notice, this looks much more simpler to integrate, and I think this is something you guys should be able to handle. So first thing we're going to do is we're going to let the denominator x minus 1 equal u. So u equals x minus 1. That's going to give us, and then du is just going to equal dx. So this is going to give us the integral of 1 over u du. And this, if you remember, is just ln of u. Okay? So now substituting back in, we're going to get ln of x minus 1. Let's see where, oh yes, okay. And then we're going to go back over here, and we actually know that 1 over x is just ln x. So now combining these two, it would have been a minus there. So we had equals ln times the absolute value of x, or of the absolute value of x minus 1 minus ln x. Combining these, this is going to give us ln x minus 1 over x. Plus c, which I have actually been dropping. But this right here is going to be our answer. So I hope that helps. I actually am a math tutor as well. I will leave my information in the description box, so if you need any more help, just let me know. All right, thank you. Bye.